Christine. Hi. So I'm trying to be math credential student. So let's talk quick thing about the survey. So for those of you who mentioned that math is quite irrelevant, I just want to comment one thing. It's important to realize that while you may not directly use the mathematics, it's important to realize that others for you and after you are using that math. So here are one of my questions. It's okay. So do you want? So can everyone take out a piece of paper and write this down? Michael, you don't even have to just answer the questions. In fact, you could write down the questions you like.
Are you kidding me?
Okay. You're welcome to participate if you want. You're welcome. Yeah.
I just don't.
So the first question: what is the highest note you can see? I know not all of you are seeing focus, but I think it's a good thing to ask. First of all, I have a question. Are all of you familiar with the music scale system or not? Something. Yes. Is there anyone in here who doesn't know at least the basis of it? Okay, well, I'll fill you in a little bit. Okay, so I'll give you about 3 minutes to answer these questions. So, yeah, it's about 11:31 right now. So, yeah, you can write them down if you wish. I think it'd be good. I mean, I'll collect them and I'll return them to you eventually. It might be nice to remember this. So I'll go experiment a little bit. What's the highest number you can see? If you want. It's okay. It's just to get you thinking. The second question is, why do you think seeing one key or one note higher or lower than that note feels very different? Very different. Third is, can you define the terms pitch, frequency, and octave? What? And fourth question is, these are all hypothetical questions. Don't worry about answering them appropriately. It's just, what does this have to do with exponential functions? What do you think? I mean, I want you to theorize a little bit. It's to get you thinking. I mean, what do you think? How do you think math relates to the art forms you're learning right now? And I want to comment one thing. You want to know that even if you're not, say, music focused, I mean, it's important to realize your art has connections to it. So it's important. So it's important we all learn to appreciate each other's art, right? Okay, so yeah, please take a couple of minutes to answer the questions. Don't worry about accuracy. I just want to get our brains thinking a little bit. One more minute. Don't worry about accuracy. Again, this is just to get you thinking.
I said I can't sing. I'm a dancer for a reason.
If it runs out of room or something. Yeah, okay, so I want to clarify, if I have to cut the lesson short because I'm out of space on my phone, I will go figure something out and we'll return. Okay?
Do you want me to pause it?
Is everyone good?
Oh, well, yeah.
Thank you.
It's like energy.
Okay, well, is everyone ready? Okay, don't worry about everything. So first of all, what is the highest number you can sing? Does anyone want to share? you know? Okay, so yeah. You want to?
No.
Okay, well, either way, it's nothing. It's nothing. We're not hitting falsetto. We're just kind of up to level. So do you ever realize that trying to sing one key higher than that or one note higher is just so much more difficult? Have you ever noticed that?
Oh, yeah.
It is, yes. In theater, when you hit falsetto, yeah, it's just much more difficult. How about one note lower? It's comfortable range. Again. Okay, yeah. Have you ever noticed that?
Yes.
Good. Well, take time. Well, if you're in a singing class for those, or even for those of you who aren't in singing arts, take a moment to think about. I mean, maybe just try singing as high as you can. Realize, oh, why is this so much harder? Huh? Okay. Well, so now let's talk about pitch, frequency, and octave. Does anyone want to define one? Does anyone want to define? Okay, Sarah.
Pitch would be the note, sound wave. Frequency would be vibration. Oh, do you want all of them or just one?
Yeah, whatever you want, and then Emily, you can give one. Or you can yeah.
Octave is like just an eight notes.
8 notes. Okay. Okay. Well, so let's talk. Notes. Okay. So let's. Okay. Does anyone want to elaborate further? So frequency. Okay, I'm going to say pitch is defined by frequency. Well, let's define what is frequency. Well, frequency. Sorry. Can you see this by the way?
Yeah.
Sorry, my mind's a little small. Okay. Frequency is defined by how many times it vibrates. All right. How many times per second?
I put the rate of sound.
Huh?
I put the rate of sound.
Yeah, well, it's an idea. Okay, well, the idea is, okay, let's think about our throats and how we sing. Okay, when you sing, your vocal cords, they vibrate back and forth, like this, you know? Now, the thing is, what happens is you vibrate frequency. So, pitch is defined by frequency. So, when your vocal cords vibrate faster, you are singing at a higher pitch. Whereas a lower one is, let's see, if you're singing a lower one, you're singing at a much lower pitch. Okay, pitch is determined by frequency. By the frequency. Now does anyone want to give a shot at how the piano works? I literally am focusing on the piano because it's on piano. Anyone want to? Sure. Yeah. Yes, and what about strings? What do you think? Yes, and what do you think? And how does it alter the pitch?
The speed or how fast.
Yes, exactly. Yeah. See, there are so many factors in it, but we'll just focus in that. Yes, something vibrating at a much lower frequency produces a lower whereas a lower pitch, whereas a much higher one, it'll produce the light thin string vibrate very fast, produce higher. So yeah, again. So now, does everyone understand this to some extent? Okay, I want you to get this idea, understand this idea because it'll really explain a lot. Okay? So how many notes are in an octave? Tell me. 8. Okay. Now actually you're wrong.
7.
There's much more than that. They're not that much more. But let's see. Let's go from C to
12.
Exactly. 12 notes.
I know, me.
Okay. Now what? Now here's my question. Now do you know the historical context of this or no? Have you heard of it? Yeah, chromatic scale, yes. Does anyone want to elaborate or what? Anyone? Half steps? Exactly. Now it comes to we're going to delve deeper into mathematics on this. But let's focus in. Pythagoras years ago in his called. Is everyone? Okay, so Pythagoras years ago, they just took a piece of string, they strum it, and they're like, yeah, produce a tone. They really produce a nice tone. They cut that string in half, strum it again. They realize, oh, it produces one pitch higher, or one octave higher. So what it is, they took several strings, divided into 12 sections. I think 12 sections each, 12 sections of the same tautness of different lengths, and they realized they created this chromatic scale. Now, chromatic scale wasn't as appeasing to the ear, so they realized, okay, we touch 8 notes. Now do you want me to, I'll go over to the piano real fast. So this is an octave, okay? Do you notice anything about it? Or does anyone know the physics behind it? Sarah?
Same note.
Same note, but why do you think?
Is it because it's like a multiple frequency or something like
Yeah, it's more it's a more you're on the right track. Yes, it is. But have you realized the mathematics? Okay, thank you. The mathematics behind it is okay. The mathematics behind it is like this. It's vibrating at the middle C is vibrating at a given frequency. Higher C, the one octave higher is vibrating at twice that frequency. Okay, so right now, do you have calculators on you?
No, they're in the calculator.
Okay, well, that would be nice, huh? I don't know if I mean, they were locked last time I checked. Okay, well, that's okay. So I'm going to give you a function. This is a famous exponential function. Okay, don't worry if you don't understand everything, but this is, okay, here you go. Okay, so what is,
N?
yes, you're welcome to write this down. What do you think this represents? Don't worry if you don't understand, it's not the folks.
Is that like standard tuning?
Kind of, yes. By the way, do you know what A440 stands for?
That's the tool.
It's like the tuning standard in. Is that N minus
They changed it
44
to
or N
more
minus
49.
49? Is there like things
Well, let me actually.
things are going up.
440 is this number, right here. That's the A. And what do you think? Which key? That's the point. What that means is it's vibrating. That string in there is designed to vibrate 440 times per second. Now that's the standard key. Does anyone? That's the standard center key. But which note is that? Start if on say look at the piano. If that is the first note, which note is this? You know, hint. It's somewhere in here. Which note is it?
Is
No, but what number is it? Which key number? 6. No, it's on the piano. It's in this formula somewhere.
12. A2? 49.
49. It's the 49th key on the piano.
Oh.
Yes. So this is kind of our reference point. Yes, this is the 49th. Yes. Okay, so so actually there are other ways to write this formula, but I apologize for my bad handwriting, but okay, so now does anyone happen to have a calculator on them? Or
Yes.
okay, well if you like to let's calculate some numbers. Okay. Again, I mean, I have some. Okay, let's see. Okay, so let's do it. So let's count. If this is the key, this is middle C, 49. What is this key? C. Count. Sorry. Which note would it be? And don't forget, you have to count the black keys. 52. No, count it back.
Oh, wait.
C.
From middle C to below.
Yeah, what's middle C?
40?
40. Let's see. 49, 48, 47, 46, 45, 44, 43, 42, 41, 40. Yes. Okay, so what number will we put for n in that function? 40. So this is middle C. 40. And so put it into your calc. Do you happen to have calculators on? Or does anyone here want to calculate that? Or you can use your phone if you want. I'll let you calculate. 40 minus 49 over 12 times 440. Okay? So let's figure out what the frequency is. What the frequency of middle C is. As in the note we start on when teaching music. What's the frequency? Does anyone want to put it in your calculator and figure it out? Okay, sure. Take your time. It's okay. Again, this is an introduction to exponentials. Don't worry, this probably won't appear on your test. This is just to give you, I just want this one.
Oh, you're having a
No,
test.
no, I have the answer. Okay, just be careful to try using parentheses properly. I'll try. 40 minus 49 is over 12. Again, I want to comment one thing. I would not test too hard. I would not test too hard on the mathematics of this. I mean, I would just.
I got the same number.
Let's try it again. Well,
Negative 660.
okay, I'm gonna put it in my calculator.
I say C.
Okay, let me get my calculator out. Okay. Okay, so let me show you how this is done. Oh, can you see this? Okay, I'll hold it this thing. Okay, so let me show you. So you go like this. You gotta do a 2 to the exponent. So 2 parentheses 40 minus 49 divided by 12 parentheses. Then multiply everything. Actually, no, let's go back to the front. I want to add a parentheses here. Insert. Okay. And then multiply by 440. It's 206. So I got 261. Oh, sorry. I'm sorry. So it's. Did you say 261? So let's. Okay. So if you want to go back, I'll show you the steps. We had to go like this. I apologize that you start here. You had to put a parentheses here. Move over. Type everything like this. Divided by 12. And then multiply 40. And you get this answer. 261.6255. Okay, so let's just write this. Well, I'll round it to about 3 places. 6, 2. Okay, now let's figure out high C. Okay. Okay, sure. Now let's see. This is middle C. Let's go figure out high C. Oh, okay. So let's interpret this. Do you know what this means? And about units for this.
Vibration per second?
Yeah, 260. Yeah, vibrates 261 times per second. So that means your vocal cords are working. When you sing middle C, they're basically vibrating at roughly 261 times per second. Yeah, 260 or 262 around there. Let's talk about. Okay, now let's calculate one octave higher. This note here. Okay. So how many notes is this from A? From A. This one's a much shorter count. 1, 2, 3. It's 3, right? It's 3, right? Yeah. So it's technically the function would look like it would be 52. You want to use. So now, do you want to calculate this? And trust me, you. Let's see. I have the numbers right here. So I can. No, 2 to the exponent. I'm so sorry. Oh, it's an exponent here.
Oh,
So this is an exponent. Oh yeah, I'm sorry if I didn't get it clear, but it's an exponential function. The concept of an exponent means that you're multiplying by that number itself that many times.
This is 500.
Huh?
500.
Yes, it is. Yes. Does everyone get that number? Or it doesn't matter if this is fine, it's not a big deal. So that means so does you want to interpret that? Anyone want to interpret that?
Yeah, it's twice the size of one.
Exactly. Okay. So yeah, so basically you sing an octave, yes, right here. Yes, somewhere over the rainbow. Yes, like yes, that's it. It's an octave. Yes, suddenly your vocal cords vibrate twice as fast. Now let's think about the keys next to each other. Okay. So now let's think about the keys next to each other. So you notice there's a 12th root right here. Okay. Well, okay. What this means is that each subsequent note on the chromatic scale is roughly 1.0594, or it's roughly that much. What does that mean? It means that for each subsequent note you sing, your vocal cords are vibrating roughly 1.059 times faster. Which it might not seem that much, but then when you get to hundreds, this number starts to get a little bigger, doesn't it? So aren't you working, isn't your throat working kind of harder on it? Yes. So yeah, it's about, yeah. So again, the concept of exponentials I want to say is that you're multiplying each number by a subsequent number, okay? Yeah, so let's see. Okay, so does anyone want to experiment? Does anyone want to sing the highest note they can sing and then try to sing one note higher and one note lower? Does anyone want to experiment? Any volunteers? Volunteers, theater majors, music majors? Okay. Want to demonstrate? It's fine if no one. It's fine if no one does it. Although I think it's a good experiment. Huh?
We should get the actual vocalist musicians.
Just I can see that.
The reason why the reason why I want human voices in particular is because you can actually experiment with how it sounds. Whereas on instruments, each instrument is different. Yes, a string instrument, a wind instrument, yes, they have their different, they have the inner workings different. Yeah.
Also, like instruments can talk, so I'm gonna ask them if it's harder or not.
Yes. Okay, yeah, okay. Is there anyone else, does anyone want to, yes, does anyone want to know or want to talk about it? Or? Yeah, so basically for each subsequent note you're singing, your vocal cords have to vibrate 1.0594, or roughly this many times faster, which gets harder because that number gets bigger as you go up the scale, right? And likewise, when you go down the scale, it gets harder because at some point your vocal cords aren't long enough, like they can't vibrate as slow as you want them to. So yeah, every person has their own singing range. So it just depends on how your vocal cords are. And remember this is theory. This is only a model. It's not perfect. Indeed, some of us have different biological capabilities, and sometimes our throats feel raspy that day, or so on. So that explains a lot. So now let's talk about social implications. Let's talk about social implications of this. Okay. Have any of you ever sung in one key, and then they realize this is too high for you, and they just bring down one key lower, and it's so much more easier to sing? Or it doesn't matter. Does anyone want to talk about it, or anyone want to talk about why do you think that is? Anyone? Okay, well let's see. Let's go. Okay, well look at this. Okay, well either way, what I want to talk about is yes. Ultimately, yes. For someone who writes music, or for theater. For opera, for musical, etc. They have to go through and figure out. Okay, what is the average note someone can sing? How much of a range I can sing it, I can create it, and so forth. They have to put this in mind. Okay. Likewise, computer software does not register ideas like thoughts on this. They just register what notes you can sing. Whereas, have any of you ever experimented with software like this before? I mean, I'm not familiar with it, but yeah, but if you can sing into it, they will measure like your range, and they will try to see if they see songs that are suited for you. Likewise, yeah. Do you have any? Does anyone here have any? Does anyone here have anything they want to talk about on this? Or no? Come on, say something. Huh? Okay. Yeah. Does anyone want to say anything or? Yes. Okay, let's see. So yeah, do you want to say anything or no? About how theatrics work. Have you experimented with it? Do you have any experience on that?
You have so much experience.
Okay. Did any of you have a singing experience where you had to hit falsetto, and it's just that difficult?
I mean, I was in the shower singing Beyonce, and I was like, it's too high, so I'm gonna
Yes. Okay. Yeah. When I was in choir class, I remember we were singing. It was our final for the semester, I believe. And really, when we didn't practice without the piano, there was always one person. Eventually, he joined the show choir eventually, but he always sang one key or one key or one note or one key lower, and I was like, you're kind of changing octaves, and he's like, yeah, I have some difficulty singing the higher octave, but well, no, I mean, ultimately when the piano accompaniment came in, he couldn't sing off key, but I was like, you kind of sing off key, so it's just, yeah. Okay, I mean, does anyone want to bring in their theater experience over?
Well, so that sometimes those arrangements in the orchestration and the chord didn't work. It was like flat nine, so like C and then D flat, the octave up to the sound of the and there is like being off key, but it's like two really close notes to each other.
Yeah, exactly. C, up a bit higher into the octave, right? Yep.
This could be kind of like off topic a little bit, but do overtones have anything to do with like the frequency of the pitch?
I'm not, what exactly, can you clarify?
It's okay, you don't need it, it's fine.
Go for it.
Well, overtones are like, it's like if you play like a chord or you have like just a note or like a choir singing there, you can hear like notes above that,
Yeah.
but that no one's singing just because they're like overtones.
Yeah, there are.
It's like reminders of like the frequency of a lower rate that produces other notes that are like, yeah, I know what you're saying. I don't think it has anything to do with that. Like,
Is
the
it what it
actual
sounds like
system.
there's more notes than what
It might. I mean, sometimes certain notes, certain pitches incite higher pitches or lower. I mean, it just happens. That's in deeper physics. This is not. It's not. I'm not going over that, but there is further information on that. May I ask how am I in on time? May I ask?
29 minutes.
Oh, okay. Well, 29 minutes. So yeah, I only had a 20-minute lesson, but thank you very much. Is there anything else you have questions on, or? Yeah. Well, thank you very much. I hope you